All right, I'm going to work two more flow rate problems for you, with you. The first one is from the 2004 Form B exam. So go to your 2004 packet and skip back to the second half of it, Form B, and it's question number 2. All right, you should take a minute to read it. I always advise you to read the whole question before you really start anything. One of the first two questions that you know is going to be on the calculator part. So one of the things you probably want to go ahead and do is put this first function in line 1 in your calculator. You might as well label it on your paper as well. Okay. The next thing you want to do when you read this problem, you recognize it's one of these rate questions, how things are flowing or how they're changing. You want to stop and jot down somewhere what your units are. All right. So R of T. Go back up and read it again. It's measured in mosquitoes per day. So R of T is a rate of change. It's sort of like velocity, all right? So there's a fairly good chance that you're going to have to go in both directions with this. There's a fair chance that you're going to have to take the derivative of this. And if you take the derivative of it, then your units are mosquitoes per day, all right? And there's also a good chance that you're going to have to take the antiderivative of it. And if you take the antiderivative of this, your units are going to be mosquitoes. Now, one of the things I did not say in the first lesson, and I'm going to say here, is I think it can be very helpful to give this antiderivative a name if they don't give one to you in the words of the problem. So since this measures the number of mosquitoes, I'm going to label this as M, all right? And that way I can think of it as a separate function. So this one, the antiderivative is the function for the number of mosquitoes. R is the rate of change of the mosquitoes, and R prime is the rate of change of the rate of change of the mosquitoes. All right? This just sort of gets you centered for what the questions are going to be. All right? You go back and you read question A. And question A says, show that the number of mosquitoes is increasing at T equals 6. So how would you show that the number of mosquitoes is increasing? I'm going to actually write that down. If the number of mosquitoes is increasing, if the rate is positive, the derivative of mosquitoes. So that means the derivative of M, and the derivative of M is R. Okay, so what we want here is to find out if R of 6 is positive, because they said time equals 6. So once again, if I want to know if the number of mosquitoes is increasing, then I need to look at M prime, and in the notation that I have used here, the derivative of M is R. Okay. So all you have to do is type into your calculator, Y1, on the home screen, type in 6, you can get a number for that. You should get 4.4379, which is greater than 0. And that's all they need to see. This is a one-point question. You pretty much had to have all of it. You had to have this part in particular has to be there somewhere. Okay, you can't just say that it's 4.4. You have to actually tell them you know that you're looking for it to be positive. Okay, I should stop saying yes since I put you all over that. All right, the next question, B. Question B says, at time 6, is the number of mosquitoes increasing at an increasing rate or increasing at a decreasing rate? They're talking about, is the rate increasing or is the rate decreasing? Is R increasing or decreasing? And if you want to know if anything is increasing or decreasing, you look at its derivative. In question A, we wanted to know if the mosquitoes were increasing. So we looked at the derivative of mosquitoes. In question B, we want to know if the rate is increasing or decreasing. So we need to look at R prime, positive or negative. That's what we're looking for. So if you write this down, let's see, did they give us more than 1 point for this? They gave us 2 points. They probably would give you a point for just getting written down. Make sure that says R prime of 6, not just R prime of 10. Okay? So how do you get R prime on your calculator? You use math, I think it's math 8. Okay, so type in math 8 at 6, and you should get negative 1.913. And so when you want to make sure you're going to get full credit for your analysis here, make sure you identify that this is less than 0. Then you can say, therefore, the rate, the number of mosquitoes, or the rate is increasing, sorry, is decreasing. Slow down. The rate is increasing at a decreasing rate. The tricky part about this problem is recognizing that for question A, you needed to do R of 6, and for question B, you needed to do R prime of 6. I'm going to go back up here and just talk about notation. I put a Y1 for A. You can do that only if you have clearly established that Y1 is the same thing as R. If you didn't do that, make sure that instead of saying Y1, make sure you say R. That's got to be clearly established. All right? So I'm going to erase A and B here just so I can keep working up here near the where I have all my information. Take a look at question C. Question C says, how many mosquitoes will be on the island at time 31? Okay, so since question C is asking for a number of mosquitoes, you know that you're going to do the antiderivative of R. And again, it's kind of nice if you stuff this name on here. Sometimes they do it for you. Sometimes this question would say, suppose that M of T represents the number of mosquitoes on the island. Sometimes they'll tell you that, but if not, it's okay for you to give it a name like that. Keep in mind that when they ask you for number of mosquitoes, you're not just going to be looking for the definite interval from 0 to 31. Okay? That's only going to give you the amount of change. You have to put the initial number of mosquitoes at the beginning of this problem. Sometimes they tell you that M of 0. This one, it tells you in words. There are 1,000 mosquitoes at the beginning of this problem. So this is the computation that you need to do, and then round your answer to the nearest whole number. Once again, this is a calculator question. This question is actually worth 2 points also. 1 point for getting this written out correctly, and 1 point for coming up with the answer 964. Okay. And then the last question for this problem is one that we did not do when I worked the first one the other day. This one asks you to find the maximum number of mosquitoes. So this pulls back in something that was not connected to these problems before. Maximum number of mosquitoes. All right. To find the maximum or the minimum of anything, you need to look at the derivative. You want to look at where the derivative of the mosquitoes. So not the M, but the M prime or R. You want to look at where R changes from positive to negative. I could say R or I could say M prime. That makes a little bit more intuitive sense. Where does M prime, the max number of mosquitoes? R changes from positive to negative. And to do that, you need to get that graph on your calculator. And I don't have a picture of that on my calculator right now. But make sure you pay attention to your window. It needs to go from 0 to 31. And you're looking actually at the graph of R.
Due to the interruption, the varsity soccer team may now be dismissed, and good luck.
I think I remember it looking something like this, but I'm not going to swear that. I'm pretty sure it did. This is the place where R changes from positive to negative. And so you need that number right there. And that's finding that 0 is 7.8539 something. And make sure you store that number. That's way better than rounding it. The rounding can sometimes cause you to get off by just a little bit at the end. Okay? Now that's just the first step. Because there are two different kinds of maximums. There's relative max, and that's what this is. There's a relative max max at this time. But I need to know the absolute max. When were there absolutely the most number of mosquitoes on this island? And to go to absolute max for men, not only do you have to find the relative max for men, but you also have to do the endpoints. So what I'm going to write down to justify this is I'm going to use this notation where I've called it M. M of 0. At the beginning, there were 1,000 mosquitoes. And then I'm going to say, at this time that I found it, my relative max, 7.8539, I need to figure out how many mosquitoes there are. Then I need to find how many mosquitoes there are at 31, and I already did that, 964. That was part C. Already found that answer. Okay. So now I have to go back and find this answer. You do it exactly the same way that you found the other answer. You start with 1,000. That's what I started with, and you do the amount of change. But instead of going from 0 to 31, you go from 0 to 7.8539. And I recommend that you have that number stored and that you actually say from 0 to A of RT. So this is the same thing we did in step C from 0 to 31. Okay? And then when you compute this value, you come up with, round to the nearest whole number is 1,039. Whenever they ask you for max or min, you have to consider the beginning, the end, the endpoints, and any relative ones. And this time it did turn out that the relative one was 1039. Now, I mentioned in class, this is not part of this question, but I have seen this question asked with a graph before, where it looks something like this. I don't know, some big piece like this. You've got some area here. I'm going to say this area is 5, and I'm going to say this area is 20. And if you know that you started with 1,000 mosquitoes, then this section, this is R, which is M prime, okay? This section says that the amount of change was 5, so we added 5. And this section says that the amount of change was 20, but it was negative, so we took away 20. So I have seen this same question asked where you have to analyze the values using area rather than actually computing. All right? Okay, that's how that one works. The next one we're going to do is 2005 exam. And it is question number 2. Not the form page, it's the regular one. It's about sand and the tide, moving sand on and off of the beach. So once again, I suggest that you pause for just a minute and read that question all the way through just to get a sense of what's going on there. Okay, I've written down my 2 equations. This is the way that this problem differs from the ones that we did before. This time there are 2 equations. The equation R, which I'm going to put in my Y1, represents the amount of, get my units off here. RT is cubic yards per hour, so that's yards cubed per hour. I've also seen people do cubic yards like this, but the first one is actually one that I'm the most familiar with. So that's our rate, and this is sand in. Oh, this is sand out. This is sand going out of the beach. And over here, S of T is also in cubic yards per hour. That is the sand that is being brought into the beach. So first it's going out, the second one's going in. All right? If I take the derivative of this, and I'm going to get yards cubed per hour, and the same thing over here. These are just good things to jot down. And And if I take the antiderivative of this, it's going to give me yards cubed, which is amount of sand. They are almost certainly going to ask you how much sand somewhere in this question. And if the integral is ST, is also going to be yards. How much sand? Okay? So those are your units. Right? They also give you one other piece of information. They told you the initial amount of sand was 2,000, also 2,500. That's how much was there at the beginning. Okay? All right. So it's going to start with A and see what it's asking you to do. I'm going to write them all down. I'm not even going to compute any of them right now. I'm going to go just right through and write them all down. So question A says, how much sand? As soon as it says how much sand, you know you need to do this. How much sand will the tide remove during the 6-hour period? So the removing is the one that they call R. How much sand will it remove during the 6 hours? Okay? The antiderivative of the rate of change is going to give me the amount of sand. Okay? That was 2 points. One for writing it down and one for giving me the answer to it. I'm going to leave this and then just keep writing the statement down that you need to do, and then you can go back and do them on your calculator. The second question says, write an expression for y of t. Okay, if they tell you to write an expression for y of t, then write y of t equals. You've got to figure out what that means. The total number of your cubic yards of sand. Okay, so if I'm going to know how much sand is on the beach, well, I'm going to start with how much sand is there to begin with. I'm going to add in any sand that was added, and I'm going to take away any sand that was removed. Okay, from 0. Okay, I'm going to be a little hand wavy here for a second. Okay, I've left all the variables out. I want you to notice. This is a little thing that I think when they graded this, they were pretty lenient on. Your final answer has to be in terms of t. So when I take this antiderivative, at any point in time, I'm going to integrate from 0 to t, not from 0 to 6. That would be the amount of sand at time 6. If I wanted at some undetermined time in the future, I need to say from 0 to t. All right? And these have to be a t because this is a t. Now that being said, I can't stick t right here. That doesn't make any sense. So we're going to have to just pick a different variable. This is one of those change of variable situations. It doesn't matter what you pick as long as you pick something that wasn't there before. And if I'm just going to pick x because that's what's in my calculator. When I got it in my calculator, it actually says, whatever that problem was, 2 plus 5 sine of 4 pi x for 25. So I'm just going to make that an x. If you take the antiderivative of this function in x and then plug in t, it's going to turn into a function in t. Okay? That's all you had to do. Just write it down. Okay? Then question C. Oh, I got one other thing. Some people wrote it this way. And they just wrote one antiderivative. S of x. Okay. Sorry. They just wrote S of x minus R of x dx, and that's also a perfectly acceptable answer. You didn't actually have to compute anything for this. I actually gave 3 points for this. They gave 3 points for getting this part right. Sorry, getting this part right. And they gave another point for getting this part right, and then for including that part in there, not you perfect. Okay. Question C. Find the rate at which the total amount of sand is changing at time t. The rate of change of the sand means y constant. Okay? The rate of change of the sand means y constant. So there's 2 different ways that you could write your work down for this, but you have to recognize that you are looking at the rate of change of the amount of sand. So I'm going to do it by looking at B. I've got y up here, this is y, and I want to take its derivative. What's the derivative of 2,500? It's 0. And think about this, what is the derivative? I made kind of a mess here, let me clean it up a little. Okay. if I take the derivative of the antiderivative, what am I going to end up with? Take the antiderivative here, and then take the derivative. It's going to just take you right back to this with a change of variable. So you need s of t minus r of t. I'm going to get s of t minus r of t. Some people recognize that without actually saying they're taking the derivative, but that's all there is to it. And this question asks you to do it at t equals 4, so you need to say y prime at 4. Go back and find s of 4 minus r of 4. Okay? The difficulty in this problem is not the computational part, it is in reading and analyzing what they've asked you to do. What is it I'm trying to find? All right, and the last question says, when is the amount of sand on the beach of a minimize the amount of sand? So in order to minimize the amount of sand, I need to look at y prime, the derivative of the amount of sand. I need to look at where is y prime. This I'm changing from for a minimum. I need, where does it change from negative to positive? And that's going to give me my relative min. I'm going to get a value. You need to store it in the memory compartment A. All right. Y prime here. Y prime is s of t minus r of t. So there's a couple ways to do that on your calculator. You can either make y3 equal to s of t minus r of t. I think that's the way that I did it. I think somebody said s of t equal to r of t. There's a couple of different ways of doing that, but you need to figure out where s of t minus r of t changes from negative to positive. And then you need to do the endpoint. So you need to say how much sand is on the beach at the beginning, and that answer is 2,500. You need to say how much sand is on the beach at the relative min. You need to get that value. And then you need to find how much sand is on the beach at the end of the problem. And I don't think we have any of those numbers. You can use it exactly the same way. I started with 2,500. And I need to know how much did it change from 0, it's not 0 to 6, 0 to A here, and here 0 to 6, S of t minus R of t, dt. Okay, you're going to get 3 values. You are going to pick the smallest one. All right, and in this particular problem, they actually had, they did ask you to measure units in question A, so we have to make sure that those units are right question. All right, in class we did not answer these together. I have the answers to this, but you can also find them online by just Googling a few things, going to the AP website, and that's it.